we would want to look at laws of indices. So first of all, what is an index? So indices, they're just basically numbers of or algebraic terms that are in index notation. So you can define them as what? As numbers or algebraic terms in index notation. So what we mean by the saying they are in index notation, let's look at this, where we are given a to the power of b to the power of x. So let's say x is our power, then a is our base. So this power is also called a what? An index. So when we are studying my indices essay, we are going to be studying my numbers or my algebraic terms and my powers. So when we're talking about indices, we're talking about powers. We're talking about numbers with powers. So there's something special when we have bases are the same, or we have bases akafanana, and it. So if we have bases akafanana, we can then now have what are called laws of indices, because my bases akafanana, they are able to interact. For example, we have law number one. Law number one here do not suggest kuti a to the power of x multiplied by what? A to the power of what? Y. This would then give us a to the power of x plus y. But then if the bases were different, let's say for example you have a to the power of x then multiplied by b to the power of what? To the power of y. Because we have a and we have b, the bases are not the same, so we were not able to apply this formula if these are in this state here. So we want to also consider another example under law 1, where we have an example of let's say numbers. So let's say we have 10 to the power of 3 multiplied by 10 to the power of 7. This will be equal to 10. So since the bases are the same, we can apply the first law of what? Logarithm. Saka innovator 10 to the power of 3 plus 7. So that becomes what? 10 to the power of 10. So that's how we apply the first law Rema indices. And we can have the second law. The second law redu suggest a division, and so we have a to the power of what? X divided by what? A to the power of what? Y. So since they have the same basis, it will be equal to a to the power of x minus y. So that would be our solution. Then if we are possibly we are given yedu isiri in terms of the division sign yedu isina kudai so let's write it, maybe possibly it will be 2a squared divided by 3a to the power of 4. So if we are given it like this, we would say the numbers, they divide each other. Takuti vatati 2 over 3. Then we have a, since a na a rakafanana, then we would get what? We would then get a to the power of 2. But since it's a division, it could be 2 minus 4. Then we then get 2 over 3 a to the power of minus 2. And still on this law, we can find Panama different letters. For example, you might have possibly you have 4a squared b divided by 3a to the power 3 b to the power of 2. So if it is like this, we are going to do it separately. So the numbers rectangle will give us 4 over 3. Then we have another a value innovator a to the power of 2 minus 3. Then twenda futhi banana b innovator b to the power of what? 1 minus 2. So kana yadai so yakuchibva 4 over 3, then a to the power of 2 minus 3, that's what? Minus 1. Then b to the power of 1 minus 2, that's minus 1. So this will be our solution. Then twenda ku law number 3. Law number 3 yedu iri kusuggest that a to the power of x bracketed to the power of y is equals to a to the power of xy. So whenever we find my brackets just know they represent what? Multiplication. So brackets, whenever you see brackets, my brackets, it represents multiplication. So we are saying that a to the power of x then to that y. So which means richa multiply na ababa, it's only what? It's going to be x nashi na y. In other words, inengeri a to the power of what? X multiplied by y, which is the same as a to the power of what? X y. That will be the figure. So let's say, for example, you are given values. Maybe you are given 3 to the power of 4, all of it squared. Then that is going to give you what? 3 to the power of 4. Then 4 and 2 are going to multiply, so that will be 4 by 2. So that will be equal to 3 to the power of 4 by 2, that's 8. So it is going to give you what? 8. But my laws of indices, my key important things, that is number 1. Any number to the power of 1 is equal to the number itself. For example, you have a to the power of 1, it is going to give you a. So if I have 3 to the power of 1, it is going to give me 3. If I have x to the power of 1, it is going to give me x. If I have b to the power of 1, it is going to give me b. So that's the first important key. Then the second one is that any number raised to the power of 0 is equal to 1. So let's say we have b raised to the power 0, it's going to be equal to 1. Let's say we have 10 raised to the power 0, it is going to be equal to 1. Let's say we have 545 to the power of 0, it is going to be equal to 1. Or times c to the power of what? 0, it's going to be what? 1. So anything raised to the power of 0 is going to be equal to 1. Then tiri ipapo, we have a special thing chiripo chatinofanira take note of. Minus 2 to the power of 0 is not the same as what? Minus 2 in brackets to the power of what? 0. We want to look at it, and sakatikanzi minus 2 to the power of 0, what it means is that it is going to be minus, then we have 2 to the power of what? 0, like this, right? So your answer, your solution will be equal to minus 1. Then again, we have minus 2 all of it to the power of what? 0. So minus 2 all of it to the power of 0 is going to give us, this is just the whole number, it's going to give us what? 1. So you have to take note of these two. The other one will give us minus 1, and the other one will give us what? 1. Then we go to the last point, which is that any number raised to a negative power is equal to the inverse or reciprocal of the corresponding positive power. Okay, and any number raised to the negative power is equal to the inverse of or reciprocal of the corresponding positive power. Angoriwo majargon angoripo, but if you raise anything to the power minus, tinobva tazoti is equal to 1 over that that thing isna a negative. For example, we have a to the power what, to the power minus what, 3. It is going to be equal to 1 all over takuti a to the power of 3 pane pasina negative, so it becomes a to the power of what, 3. That's what the statement means, and it. So if we also have maybe possibly we have 6 to the power of what, negative 5 over 3, it would be just the same as what, 1 over what, 6, of which 6 would be equal to what, to the power of what, 5 over 3. So that's what it is like. Even maybe we might have x to the power of minus what, 7, it will be equal to what, 1 over x to the power of 7. So that sums up our lesson per introduction ima laws of indices. So that's the basic. We have law number 1, law number 2, as well as what, law number 3. But chakakosha pama indices is that the base is supposed to be the same. So if the base is the same, those laws can relate.